All right, now we'll get back to the questions in just a moment, but now we want to welcome Tim back to the show.
Hey guys,
Welcome
good
back,
to see you
Tim.
again.
Good to see you
Always
again.
a pleasure.
Always. And today we're going to
your
work on.
graduated cylinder
We
with
did
you.
bring it. I'm not sure what school it graduated from, but it was a big one. That's all that
I'm
matters.
really anxious to see elephant toothpaste.
Well, we like to call it Mastodon toothpaste
Oh,
because
that's
we have
right.
a
I did hear you
Mastodon
mention
at the
that earlier.
museum. But it's pretty cool. It's actually the catalytic decomposition of hydrogen peroxide.
There's a lot of words in there that I don't understand, so I'm sure you'll
Well,
inform
what's
us about it.
decomposition? When you think of
Well,
decomposition,
then I
what do you
think I know. And then it's the breaking down of
breaks
something.
down.
Yeah,
Something that
part I
breaks
got.
down. And how about a catalyst?
And I might need a little bit of
How
help.
about if we had a cattle prod and you had a cow
move
and you
something
touched
along, yeah.
move it along a little faster.
Faster,
Well, that's
okay.
what a
That's a good
catalyst
example.
does. It actually quickens or speeds up a chemical reaction. It's like, it's, well, you'll see, because what we're going to do is we're going to work with hydrogen peroxide, which happens to be H2O2. 2 hydrogens, 2 oxygens. As a matter of fact, these balloons are going to help us out.
H2O2.
Now, we've got 2 moles. You got hydrogen peroxide here, hydrogen peroxide there. What could you make out of those
Can I
two?
answer that one?
Sure.
Okay, I'm on a roll here.
Okay,
I feel a little
you are.
better. Well, if you take away one of the O's, you got water.
Yeah,
Well,
right.
all right, so what we'll do is we'll take this right off.
Oh, look at you.
We'll take one of the O's away, and we'll give you that water.
You're a
All
water
right,
now.
I have a water.
So now, you get to hold on to this O for a second.
Oh, but
hold
I don't
tight.
want to be
These
by
will go
myself.
away.
Oh, that's all right, because we've still got another one over here. So what can we
Oh.
make with that?
Same thing?
Same thing.
All right.
Yeah.
I feel like
Another
I'm doing
water?
well today.
And
the
let's see if
oxygens
I
don't
can
like
figure
VO,
out
see.
which one is the loose one. Might be, grab that one right there. I think it's that one
Okay.
right there. There
Got
it
it.
is.
I'm still
All
going to
right.
get
So
2
there,
waters
you got
now.
2 waters.
All right.
So
All right.
now you've got 2 waters and we've got 2 oxygens.
Okay.
This is what happens when hydrogen peroxide breaks down. It breaks down into water and these 2 oxygens, which are
Never
O2.
knew that. Okay.
And O2 is what we take in, oxygen. It's a
Oh,
gas.
okay.
So that's what it breaks down into. And the catalytic decomposition of it, what we're going to do is we're going to break down some hydrogen peroxide. Now this is 30% hydrogen peroxide. The kind that you have in your little brown bottle at home, that one is going to be about 3% hydrogen peroxide. This might be the stuff that your grandmother or someone's great-grandmother used to make their hair yellow
like it all
and their
colored
scalp
cut.
pink because it's a little caustic. But that's all right. So we're going to use that. We're actually going to use a little soap. So I'm going to put a little soap into our graduated cylinder right now.
Okay.
And first thing I'm going to do is I'm going to put on my goggles.
Do we need to do that?
No, you're
Oh,
good.
okay.
You'll be over, you're over there.
It'll
You'll
be crowded
fine.
in there.
And turn around. We're going to add a little bit. And that's about right.
Okay.
And that's an actual chemistry measurement.
About right.
That's about right.
All right.
Or that'll do.
Yeah.
Maybe we'll give a smidge more of the soap. So now we've got the hydrogen peroxide and the soap mixed together, and we're going to break it down into water and
Oxygen.
oxygen. So if you've
Okay.
got
I don't know if
soap,
he's looking at you or me.
yeah, so you've got soap, water, and oxygen, and you mix it together, what do you think you're going to get?
Hydrogen peroxide. Is that what you told us?
But if
Well,
you
the
mix
water's
them
gonna
all,
be-
the water
I need help
mixes
here,
with
I
the
don't
soap,
know.
Yeah.
and then how about water,
We'll get
soap,
bubbles.
and air?
You're going to get bubbles.
Okay. All right.
We'll get bubbles.
I'm in.
Yeah.
Now, what we're going to use for our catalyst is potassium iodide. And so that's going to break it down. Maybe, Mr. Z, you could
That's
talk
gonna give
about
us
what
bubbles.
a catalyst is. How
Well, remember we said earlier, catalyst speeds up reactions.
Right, moves it
so you
along
actually
faster.
have a catalyst in our body because our body produces hydrogen peroxide.
All right.
Needs to get rid of it.
All right.
Because it could be dangerous to the cells, and so you have a catalase enzymes in our body, all living things that get rid of this. So the same thing's happening. So this is going to make it happen much quicker.
much faster.
Okay.
That hydrogen
okay. That way you
peroxide-
can see the elephant toothpaste that much faster.
Well, the hydrogen peroxide would break down on its own. It breaks down because of light alone. That's why it comes in the brown bottles,
Exactly.
but slowly.
Never knew that.
Yeah.
And the other thing,
more-
when a chemical reaction is sped up, it gives off heat. It's an
right.
exothermic reaction. It's like if you take your hands and this is your chemical reaction, and you start speeding it up and speeding it up and speeding it up and speeding it up, what do you feel?
Heat.
Heat. And that's the same thing that's going to happen here. And you're going to see, when we see it happen, you'll see some of the steam coming off the top if you really watch.
Because of the heat.
Because of
See,
the
that,
heat.
the heat
Kinda
would be
relates.
given off if we let it happen slowly, but over time you wouldn't notice it. But since it's going to happen
This
so
is the
quickly.
catalyst.
So like
Gotcha.
the hand warmers we had earlier.
I was just going to say this relates a
When
little
things
bit to
rust,
your...
they give off heat,
Pyramid
but we
earlier.
don't notice it. You know,
Okay.
when it happens quickly there.
Wonderful.
Yeah.
Let's do it.
It is. All right,
All right.
well, let's do it. So what we're going to do is we're going to take, oh, by the way, there's a little, I'll do a little add-on at the end
All
really
right.
quially, just to show you where the
Sure
oxygen
we don't
is.
need goggles.
No, you'll be fine. You'll be fine.
No food coloring, huh?
No,
look
oh,
at
no, I
that.
didn't go with the
Look
food
at
colors.
All right.
Wow, that's great. Now I know why we have this guy here. Oh, look at that reaction.
It's,
And look
notice
at
the
the
steam.
heat. I see the steam.
Yeah. You wouldn't be
this
able to
is a
see the
great
heat, but you
example.
certainly see the steam, right? Yeah.
Now, what I'm going to do, because it breaks down into water and what else?
Oxygen.
Oxygen. So
Okay.
I've got this little dowel, and I'm going to just get a little glowing ember. See if we can get it. Oh, it works better when you see it in the dark, but
Yeah.
there it is. On this side, you see it quite a bit.
All right, that's cool.
It starts to actually ignite from a dowel.
Oh, look at that. That's great. Fourth
Yeah.
of July stuff.
That's the oxygen, the pure oxygen inside. That's
Oh, look at
actually
that. What
Heating.
causes it to flame then? The oxygen,
oxygen.
just catches it?
Well, it's already burning a little bit, right?
Okay, right. It's
So
already
the ox-
hot.
The oxygen.
And so what does fire need to burn besides fuel?
And oxygen.
Oxygen.
Yeah.
So that's what all these bubbles, now it'll work for a little while. It starts to break down, especially, unfortunately, on the opposite side of the camera.
That is so cool.
But it's very cool.
Tim,
If you do a little darkened room, when we do it at the museum, it's pretty sweet.
Yeah.
And it
we can
goes
tell. We can tell the people. We can feel the heat even. a little bit
coming off
from
of it.
Yeah.
Exactly. And now, hydrogen peroxide itself is a little bit caustic, but at this point, it's been neutralized by breaking
You
down.
might want to tell us what caustic means.
Caustic means it'll cause a little irritant for your
Okay.
skin. But you know what? We did the catalytic decomposition. You have something in your house that does the opposite, that actually slows the decomposition of things.
I don't know. You're gonna have
Think
to tell
about
me.
it, where do you put your milk?
Oh, I have a refrigerator.
Refrigerator.
There you go. Okay.
Because everything in your refrigerator, the cool
cool.
part about it,
Yeah.
it's decomposing even as we speak. But actually, the cold slows
Never thought
it down.
of it that way.
Oh, you've never eaten at our house.
little bacteria.
Yeah, I know. I was gonna say, ugh.
And there we go. There's our catalytic decomposition
You did a
of
great job
hydrogen
with that, Tim.
peroxide.
That was fun.
Mastodon toothpaste or elephant toothpaste.
And I
depending
like the
on what
way
you
it
call
related to again to your experiment too.
Yeah.
We're doing the
Every now and
challenge.
again,
Well,
a
thank
blind
you, Tim.
squirrel finds a nut.
Yeah.
Well, thank you, Tim.
Yeah,
All
nice
right.
job,
so we'd
Tim.
like to thank Tim for being here tonight. And then to see this experiment again or learn more about the Rochester Museum Science Center, head to our website, homeworkhotline.org. Now stay right there, and we'll be back in a second.
Great.